All right, this is problem number 6 from 910. I'm probably being too loud because I changed my mic, but I'm sorry about that. I'm going to keep trying to talk like this level, and I'll probably be loud and quiet as I usually don't know what I'm doing. All right, so I got a coffee pot rated 360 watts, an iron rated 960 watts. I have an oven rated at 1200 watts, all connected in parallel across 110 volts, 120 volts, sorry. 120 volts, so there's my battery. It's not really a battery, it's an AC circuit. But we don't worry about that. I've got a resistor. They're in parallel, right? Wait, is a coffee pot a resistor? Yes, a coffee pot's a resistor. Of course it is. It takes power from the system by making a cruddy wire. In fact, if you open up a coffee pot, typical coffee pot, it's got all fancy things around it, but in the very middle of it's got a crappy wire. That's what it is, cruddy wire. Boop. And I got a second resistor, and now I've got myself a third resistor. Isn't this nice? And then I have 300. So this one here has a power of 360 watts, and that should cause me some confusion, like, uh-oh, what am I doing here? This is 960 watts, uh-oh. And this right here is 1200 watts. Now, again, that's not resistance, so now I'm kind of stuck in a strange box of, how do I do this? Calculate the minimum current a fuse needs in order to be able to have all these at the same time. So right here, I'm going to put a fuse, and all of the current's going to go through that fuse. So what is the least big fuse I could put there and not have the whole thing blow up? All right, so I need how much current is going through, say, this wire here. Now these things are all in parallel, so each one's going to get all 120 volts. Agreed? So if each one's going to get all 120 volts, I'm going to start with this first one and blow out the problem. Here we go. We're going to go power equals I squared R, because that's what formula I told you to use. If you're not using that formula, you probably got away with the right answer in shorter time. It'll haunt you later. 360 watts is equal to current, I don't know. Resistance is, I don't know. Oh, crud, that's two unknowns. I need another equation. Well, good news is I know I'm going to drop 120 volts from here to here, correct? So V equals IR as well, right? V equals IR. And V is 120 equals IR. So looking at this and being cutesy, I recognize that this could be written as 360 equals I times IR. Ooh, isn't that cool? So then 360 equals I times 120, and I equals 3 amps. Agreed? All right, repeating the second thing. I do the exact same thing for the second route. Power equals I squared R. I got 960 equals I squared R. I got V equals IR. I separate my variables. 960 equals I times IR. I replace my IR with that, and I get 960 equals, sorry about the bad handwriting, I times 120. Do my head, I get 8 amps. If I did that wrong, check out the calculator later and say I'm wrong, and I will accept my poor penmanship and my poor mathematics at the same time. V equals IR. I'm going to skip to the punchline. It looks like I take the power and put it here, which is 1200. I times 120, so that thing must be drawing 10 amps. So I got 10 amps going this way. I've got 8 amps going this way. I've got 3 amps going this way. So how much must be coming down this wire that's supplying the 3, the 8, and the 10? Well, that's 3 plus 8 plus 10, so there must be 21 amps in this wire going this way. So therefore the fuse must be must be greater than or equal to 21 amp fuse. And that's how I do that problem. I hope that explains it. If it doesn't, send me another post and I will, try to give me a question I can launch off of on that. Okay, thank you much. Bye.